we don't all have cancer. And I think we've spoken a little bit about this offline as well, is that there's a very, very strong difference between a normal cell and a cancerous cell. It's not like a virus where we're constantly fighting it off or some sort of pathogen. Cancer is typically a disease associated with those chronic changes as a cell develops over time that at some point, depending on our environment, depending on our genetics, basically cancer arises when basically things go out of whack. And that's not like something that's intrinsically involved in normal healthy cell metabolism, right? So it's not like I said, it's not like we're always fighting off cancer.
A very special thank you to Timeline Nutrition for sponsoring this episode. I'm super pumped about Timeline Nutrition and what they make, because they make a product called MitoPure. And MitoPure contains urolithin A. And urolithin A is a compound made by the gut microbiome. So some people will eat, or I should say drink, pomegranate juice. From that, they'll be able to make this compound from their microbiome. Urolithin A has been shown in multiple studies from multiple labs over multiple years to improve energy through mitochondrial health. And they do this by improving mitophagy. So mitophagy is essentially the cleaning up of old mitochondria. And we need this. This is extremely important because we need to be able to replace the damaged mitochondria with fresh new ones. And this is what urolithin A does. If you want to try this out, I strongly suggest that you head on over to timelinenutrition.com/neuro and you'll get 10% off your order. I strongly believe that MitoPure is going to be everywhere in the next year. I think everybody's going to be understanding why pomegranates and pomegranate juice is extremely beneficial for you, and you can now get it from MitoPure. So head on over to timelinenutrition.com/neuro to get 10% off your order. Joe Zundell, welcome to the Neuro Experience podcast.
Thanks for having me.
I'm so excited. You've probably the first person that I've had on guests that's really dedicated to this awful disease, cancer, which is, yes, associated with aging, but I'm dumbfounded a bit when it comes to this. And, my area of research is neurodegeneration and Alzheimer's disease. And with Alzheimer's disease, something that I'm always telling people is it's not a one-time diagnosis. You don't go to the doctor with these memory complaints in your 70s and they say, well, you've just gotten it. It's an accumulation over time, maybe a progression of around 20 to 30 years. And I want to know if cancer, because I've heard you say before that cancer is somewhat similar. You don't just wake up and you've been diagnosed. It's something that's been accumulating over a number of years. So why don't we open the floor by first understanding, how does it happen? What is cancer really?
Yeah. So there's, firstly, thanks for having me. Of course, I really appreciate it. And I've dedicated much of my time to trying to educate people about what is cancer. So in starting there, I'll say that cancer is a progressive disease, much like any disease, in that it takes multiple genetic events or environmental triggers to stimulate the progression of disease. Now, it doesn't mean that young people can not also get this disease. Young people can get this disease, but it's typically a disease associated with aging because of those steps necessary to trigger malignant progression or cancer. And those vary between, where the cancer's beginning or the point of origin. And so it's really hard to pinpoint what cancer is, but what I usually tell people is that it's a disease marked by consistent errors in usually like DNA replication that cannot be repaired compared to like a normal cell. So like we have all these specific checkpoints as a cell is, dividing that offer checks and balances between, telling a cell whether or not they can continue to divide. And cancer cells have essentially evolved in a way to circumvent these checkpoints to continue to divide even past their terminal endpoint. Everything in life has a start point and an end point, aka death. And I've even just posted on this regarding like the dynamic ways that cancer cells can continue to grow. But essentially, cancer cells have very programmed and specific ways that they can circumvent these checkpoints to continue growing past what is normal.
But why does it occur that way? Like, why are these checkpoints getting misguided?
Yeah, so oftentimes, again, depending on the tissue, cancer cells will deregulate some of these proteins or enzymes involved within regulating these checkpoints. So that way they can bypass them. They can continue going past them despite having like DNA errors as an example. And so by bypassing these checkpoints, they can basically just skip over them and keep going through the cell cycle and continue dividing past those points. So sometimes it's through upregulation of specific enzymes to bypass a particular checkpoint, or by downregulating a cell cycle control protein. Those are just a few of many examples. Sometimes it's through metabolic contributors. So like one phenotype we often see in specific cancers is like the increased uptake of glucose, which a lot of people misinterpret as glucose being a primary fuel source for not only cancer cells, but pretty much all cells in your body, especially the brain, like you study, very metabolic tissues like the muscle as well. Cancer cells will often upregulate or increase the amount of glucose that they can absorb for other metabolic purposes to sustain their continued growth past against what's normal.
Does that mean that does that mean we essentially shouldn't be eating sugar because you're feeding the cancer cells?
No, I wish it was that simple. So again, this is a common misconception that a lot of people have. Because I guarantee you, if you starve a cancer patient of sugar, even for a short period of time, you'll see really negative health consequences associated with that particular patient. Because again, all of your cells pretty much in your body utilize sugar or glucose to some extent. Various forms of sugar, it's not even just glucose.
But isn't this a disease of genetics as well? Because what I can't understand sometimes, like I understand that you increase your risk of cancer, of lung cancer, if you smoke. Okay. You may increase your risk of liver damage and essentially cancer if you are drinking excessively. I can't understand how we can get ourselves there like that, but then you can have kids who are born with cancer or leukemia, which hasn't been a time, that's not associated with aging, and that's not associated with metabolic damage. So how does that happen? Is that a genetic factor?
Yeah, so there are a lot of genetic factors associated with why children get cancers at a particularly young age, because as I think even we've mentioned, somewhat offline, cancers are typically associated with aging, but that doesn't necessarily mean that kids can't get it. And to be honest, the reasons why children get cancer, we don't necessarily understand because they're not common. They're rare. So we don't exactly have a lot of evidence to derive the reasons why they get cancers. But from what we know so far, most of them are genetic contributions, which again vary between cancers, like leukemia as an example. But as you mentioned, there are a lot of environmental exposures that can increase our risks for specific cancers over time, like alcohol consumption and liver cancer as an example. So there are specific nutritional considerations we all need to take into account, and how they can increase our risks for not only cancers, but other diseases like obesity, diabetes, even Alzheimer's.
So when it comes to public policy, I'd love to know what your take is on that, because I know that when it comes to obesity, for example, there's a huge uproar about what we're putting out there to the public in terms of education. I really believe that disease states, there is an education component involved with it. Let's look at Alzheimer's disease. We know that there's around 20 to 30 genes involved in the progression of Alzheimer's disease or the diagnosis. However, a lot of it is due to lifestyle interventions and factors. So is this the same case for cancer? Is there something that we don't know as a public that we should know in order to prevent cancer from occurring?
Yeah, so I think even as educators, for trying to get people to practice appropriate health considerations, Publicly, we know of a lot of things that people can reduce their risks for specific diseases like cancer or even Alzheimer's. But despite whether or not we teach people these specific things like, reducing your alcohol consumption, consuming a nutrient diverse diet, there's only so much you can make somebody do. So despite, like in the United States here, there's pretty decent public policy associated with, how we can reduce certain disease risks like cancer. But at the end of the day, it's up to each individual to listen to their healthcare professionals in the things that they can control to reduce their risks. There are a lot of things that we don't necessarily have in our control. If somebody has a specific genetic mutation, like on Gabrielle Lyon's podcast, I spoke about like Lynch syndrome as an example. It's a rare disease, but nonetheless, like I have a friend that has Lynch syndrome. So these people, as they age, they have a significantly greater risk of things like colon cancer over time. So there are a lot of things that they can't control with that, but one thing they do have control over is something like fiber consumption. So typically one of the best things that doctors will tell these people is like, go buy Metamucil. And this isn't like a shameless plug for Metamucil. I'm not sponsored by them, although I wish I was. But just increasing your fiber consumption can help to reduce the natural inflammation that comes with people who have Lynch syndrome or even other types of cancers.
It's interesting. I saw an interesting statistic around colorectal cancer being the third highest leading cause of cancers, which completely preventable because, and correct me if I'm wrong, when it can be prevented via a colonoscopy, for example, and you go into a colonoscopy and there are what do you call when you go and do a colonoscopy?
Like the actual camera?
No, the actual little lumps inside your...
Oh, polyps.
Polyps, sorry. So you'll go in and, if you get scanned and you find polyps, they can remove those polyps. Not every polyp is cancerous. Right. However, every form of colorectal cancer is caused from a polyp. Is that correct?
That is correct.
So then naturally you'd go and you'd get a scan and you can prevent your risk.
Yeah.
Okay. Now it gets a bit trickier when it comes to breast cancer because it's more of there is more to say than just going and getting a breast cancer screen, right?
Yeah. And I think typically yes, colon cancer, there are a lot of preventable factors, assuming you don't have some of those genetic conditions, but the frequency at which people get colonoscopies definitely, even if you're a healthy individual, I think most people should be having access to frequent colonoscopies to help reduce their risks.
That should be occurring. I think it's now the age of 45.
Yeah, exactly.
It was 50.
Decreasing.
Yeah,
which is good
50.
News.
Yeah.
Yeah.
Well, that's very good news.
Yeah. But again, especially here in the United States, the healthcare situation isn't exactly catered to taking care of everybody. And I have my own issues with that. I think that everyone should have access to things like a colonoscopy to help reduce their risk. But the truth of the matter is that people don't. And a lot of that is due to our somewhat individualized healthcare system.
Yeah.
It's expensive. It's not cheap. Yeah. I think even recently I've just started taking care of my own health just because I've just basically at 31 acquired decent health insurance.
Yeah.
But there are other things that you can do. But regarding things like breast cancer, depending on the tissue that the cancer originates in is going to dictate not only the treatability of that disease, but also your ability to detect it. And breast tissue between both men and women vary dramatically in density, tissue type, total mass, right? Those are just some basic things. But some people might have just like dense breast tissue, and something that might be detected upon like a mammogram may not actually be cancerous. So a lot of there is this false detection rate associated with mammograms, but I still think that frequent screening through mammograms is necessary to help reduce risks, despite some of those, I guess, false positives.
Yeah, I really want to hone in on specific topics and look at the correlation between the disease state and these topics. And I'm going to start with sleep. I always say that sleep is the most underrated high performance tool that we have and disease prevention tool that we have. It's completely free if done well and if done consistently. Yeah. So I often reference this one research study where they took a group of healthy men and they sleep deprived them for, I think it was around 6 hours a night. And what they found that over 1 week of sleep deprivation, they had changed their genome. So, they had a change in, epigenetically of 3%. So what they found was that the genes responsible for tumor growth were upregulated and the immunity genes were downregulated. Mm-hmm. So is this true? And if so, what's the link between sleep deprivation and cancer?
So there's a strong link not only between sleep deprivation and cancer, but pretty much most diseases. But there are some strong links, at least within the research. As an example, there was a recent study I was reading that utilized it's circadian metabolism. So my degree of understanding of this is somewhat limited because I'm not a circadian metabolism biologist. From what I understand in this paper, they essentially mimicked jet lag syndromes or jet lag time scaling in a mouse model, which was going to develop cancer anyways. I think it was a lung cancer mouse model. So they're going to develop cancer anyways. But essentially they found that, similar epigenetic contributions like what you previously mentioned, that the particular dysregulation in sleep patterns worsened the progression of that particular cancer. Again, I do want to emphasize that those mice were going to get cancer anyways.
Yeah.
But the added component of sleep deprivation on top of this cancer model worsened the conditions, not only from an immunological perspective, but from an actual tumor perspective in increasing the expression of specific genes which worsened that particular lung cancer.
Is that just purely because I know that when you are sleep deprived, for example, we understand now the glymphatic system. When we get into deep, slow wave sleep, we know that the glial cells shrink, allowing our cerebral spinal fluid to pretty much clear out the toxins that are, some of them that are hallmarks of Alzheimer's disease, like amyloid beta. Mm-hmm. We know that they get washed out. However, during sleep, what is it that is actually occurring in terms of these tumor cells?
The degree of that, I actually don't know.
Okay.
Again, because I'm not a particular biologist when it comes to doing circadian metabolism and onset of cancer. But from an epidemiological perspective, I can say with a strong degree of confidence that dysregulated sleep patterns is associated with greater risks for pretty much all cancers.
Yeah.
Yeah. Through the same metabolic outputs or very similar metabolic outputs that you see with something like Alzheimer's or obesity or diabetes.
Yeah.
Just because our bodies are very tightly regulated by the amount of, our sleep cycles and our waking cycles. You've heard of hormones like cortisol being increased when you wake up in the morning. And as you fall asleep, melatonin is increased to help you, get into that sort of drowsy state to go to sleep. But there are a lot of other hormonal things that occur and endocrinological, it's a big word, things that happen that kind of mediate the state of balance between what your organs are doing to help repair tissues while you sleep.
Yeah.
And if you go under a chronic period where you're not going to sleep at a very regimented period of time, you're kind of fighting against your natural physiology.
Oh, yeah.
So if you're not getting like that 8 hours of sleep per night and you're not waking up at appropriate hours, or maybe you're a shift worker or somebody like that, you're strongly increasing your risks for pretty much all cancers.
So you're pretty much saying
just go to sleep.
Yeah, just go to sleep. That's what everyone's saying.
Shut the lights off. Make sure it's dark. Make sure the room's cool. Like there's associations between temperature and dysregulated metabolism. So, we have specific adipocytes, fat cells that are respondent to temperature changes.
Yeah.
My wife is a circadian metabolism scientist, and their lab examines a lot of these things too. Like, what happens when we dysregulate specific sleep patterns, what happens on the adipocyte level, what happens in the muscle, liver. They study a lot of liver metabolism stuff too. So
it's very rare for anyone to say that sleep is not going to be it's not a good thing. What I actually am fascinated by is nutrition, because I think there is so much confusion around nutrition. You've got all these wars happening.
Confuses me, so I can't blame anybody.
Diet wars, but at what point do we know that this is correlated to cancer? Is there anything nutritionally that we should maybe prevent or stop eating just in case?
Everything in life is about balance.
Okay.
So from a nutritional perspective, it's important for humans physiologically to consume a nutrient diverse diet. And what that means basically is, as omnivorous human beings adapted to the planet Earth, we need both plant and animal sources. The degree of which varies slightly between people. But again, we need both plant and animal sources to maintain our metabolism over time. Regarding things that people should, or food sources that people should avoid, in general, you want to avoid foods high in saturated fats. I think that's pretty common knowledge. Again, public health professionals would agree on that. It's not like, one of the issues, as an example, is the Western diet. Here in the United States, we have a really, really big issue with obesity. Obesity is very, very strongly linked to cancers as well. I think 13 at this point. And a lot of that is diet-based. And a lot of it comes from people's overconsumption of highly palatable foods that are high in saturated fats, foods that have high amounts of added sugars. And you can consume those. We can all consume those. I know I absolutely love ice cream. I drink a root beer every once in a while. There's nothing wrong with doing that every once in a while. But the issue is that people become reliant on those foods.
Well, but like when it comes to sugar, I know that there, in our world, it may not really exist. It's like, okay, but there are some people who are definitely every single day it's ice cream. It's like a part of their diet.
Right.
And is that when it becomes problematic?
Exactly. So it's those chronic exposures to poor diet.
Okay.
Yeah, that can create, again, not only risks for all cancers, but literally diabetes, obesity, those sorts of things. And they all kind of like have these metabolic contributions between each other that are very, very tightly linked. So
I've been reading a book lately, and in this book, it's actually Dr. Peter Attia's book, and I'm very fond of him, and I love listening to him and his research.
Same.
And he mentions, because he speaks a lot about cancer, and actually in his book he's got a chapter on it. And correct me if I'm wrong, he says that we all have cancer cells, and that scares me.
Yeah, so whether or not, again, I also respect Peter very well. He's obviously very well respected in the scientific community as well. But I do think that he's kind of branching out of his field of expertise a little bit here. I will say that is not true, which is perfectly fine. We don't all have cancer. And I think we've spoken a little bit about this offline as well, is that there's a very, very strong difference between a normal cell and a cancerous cell. It's not like a virus where we're constantly fighting it off, or some sort of pathogen. Cancer is typically a disease associated with those chronic changes as a cell develops over time, that at some point, depending on our environment, depending on our genetics, basically cancer arises when basically things go out of whack. And that's not like something that's intrinsically involved in normal healthy cell metabolism, right? So it's not like I said, it's not like we're always fighting off cancer. We all have I can say this with confidence, is that we all have the potential for developing cancer, but it's not like we all start off with cancer unless we have strong genetic contributors, like again, those people with Lynch syndrome or P53 mutations in specific tissues, things like that.
So these P53 mutations, should we be like, where does diagnosis come into perspective? I know that we're doing that. I've heard of liquid biopsies. You can get CT scans, but does this mean that we can go and get a 23andMe test done and see what genetic risk factors we have?
Yeah.
Also, a very special thank you to Element. Did you know that electrolytes are key to cellular function, in particular neuronal and nerve cell function? Well, if you listen to this episode, you know how important hydration is for the overall body and the brain. And this is why I advocate for proper hydration no matter how much you sweat. And what is the best electrolyte solution on the market? Element, which is an electrolyte drink mix. You've probably seen it around. People are drinking, they carry around these salt sachets that are flavored. This is Element. It's a science-backed formula with 1,000 milligrams of sodium, 200 milligrams of potassium, 60 milligrams of magnesium, and 0 milligrams of junk. It's trusted by professional athletes, physicians, and fitness enthusiasts. And right now, Element is offering my subscribers of the podcast a free sample pack with any purchase. So if you are looking for a new electrolyte drink, or even if you're new to this whole electrolyte, phenomenon that I think everybody should be hydrating with, then head on over to drinklmnt.com/neuro and get your free pack. Now with all of the travel, because you guys know how detrimental travel is to your hydration status, I've been sipping on the watermelon flavored one. So head on over to drinkelement.com/neuro and pick up your free pack.
Actually, I did somewhat recently within the past year, I got a 23andMe done.
Yeah.
Just because I wanted to see if I had any sort of genetic contributions between cancers. Right, because it's my field of study. So I was interested to see if I had certain mutations that increase someone's risks for cancers. Now, I will say that even if I were to detect a mutation, doesn't necessarily mean that I'm going to get the cancer. But knowing about the specific mutation, there are certain things I can do within my life to reduce risks.
That's like Alzheimer's disease. They're risk factors that we know they're there. Doesn't necessarily mean you're going to get it. Mm-hmm. Okay.
Yeah, it's the same sort of thing. Every disease has those genetic contributions. But knowing is going to, knowing they're there is going to give you kind of power over it. And then
or it could scare the hell out of you.
It's scary. So one thing that I really try and temper people's emotions with are that diseases in general are very complicated. Yeah. And just because you have a mutation doesn't necessarily mean that you're going to get a cancer. Yes, while that might be scary, I think people need to come to peace with the fact that they're human beings. We're constantly adapting to errors going on within our bodies. You and I right now are having DNA errors that are being fixed as we speak within nanosecond range, even smaller than that picosecond range, that are just being repaired. People need to come into consensus that it's just very complicated, and we don't all have cancer upon this either. So it's just because it's scary doesn't mean that we shouldn't know, right? We have to be able to make actions about the things that we can control. You can't control a lot of those things. I mean, you can control what you eat. You can control the environments you're in to some extent, but that genetic contribution, you can't. So you just do what you can in your environment to help reduce your risks.
Yeah. And then, you would also say with that the best prevention is screening, because but then again, so for example, I've personally been affected with it. My auntie and my grandmother passed away of pancreatic and ovarian cancer. And it's quite scary because I saw from the time of diagnosis to death, it was a very short period of time.
Especially with pancreatic.
Yeah, and you don't pick up on it. So that's really obnoxious to me to think, wow, you don't feel anything. When you feel something, you go and get it checked. And when you get it checked, diagnosis, and then you're gone 3-4 weeks later.
So a lot of my research has been focused on ovarian cancer as well.
Oh, wow, okay.
And even pancreatic cancer I've studied for a very brief amount of time. But one of the issues with those cancers is you get symptoms, but by that time that you get symptoms from them, the cancer is already at a particular staging where there isn't all that much you can do because it's advanced beyond a particular stage that the treatment options are limited. So one of the issues in detecting ovarian and even pancreatic cancer is that they're detected way too late because of the lack of symptoms until they start causing problems.
Are there screening measures for pancreatic, the same as colorectal?
No.
See what I mean?
That's one of the issues.
Hope for the best.
It's a huge issue within the pancreatic field, but there are liquid biopsies now that can help to, I guess, assess whether or not someone has a likelihood for it.
Okay.
There's this test called GRAIL. Well, it was invented by GRAIL, but it's called the Galleri test. And so it's a liquid biopsy that detects circulating tumor DNA. And so as tumors develop, like I said, they acquire these specific issues or mutations. So there are tests like a liquid biopsy from the Galleri test that can detect some of these mutated DNA sequences that come from these early developed pancreatic cancer cells. And so if that test detects it, and you get analyzed by a professional, they have a reason to do some form of an actual biopsy on your pancreas to see if there's actually tumors there. But those are some sort of early detection methods that we're trying to develop, and they are getting better over time. But those liquid biopsies aren't always perfect for all cancers. They are preferential towards some cancers.
What's your take on these full body MRI scans?
Again, I add it to the amount of screening that people should get done. I support it.
Yeah.
If people have the ability to do it, but again, there's healthcare associations with that in terms of need. So at least in the USA, unless there's a need to do a full body MRI, they typically won't spend the time to get you in, do the procedure, and then analyze those results, because it's going to take away time from somebody who might need it. But yeah, I believe that healthcare should support things like those for all people.
Yeah.
Alongside frequent mammograms for women, starting from like 18 through the rest of their life. Frequent colonoscopy is starting even earlier than 45, I would say.
40.
Yeah.
Yeah.
Fuck it. 30. Excuse my language.
So what I've been reading as I was preparing for this, and I've read this in my research before. So I study the myokine pathways, these hormones that are secreted from skeletal muscle in response to resistance training, and how they have an effect on our cognitive functions, for example. And I came across this one paper, and it was related to the myokine pathway and prostate cancer. So for everybody listening, I'm alluding to the fact that when you exercise, specifically resistance training, we'll call it, but also aerobic physical activity, this can be beneficial to maybe prevent the onset of certain cancers due to the hormones that are released during exercise. Is that what's the relationship between exercise and cancer?
Yeah, so there's a lot of relationships between exercise and reduced risk. So I'll say if you're going to focus on two things that you can do, it would be appropriate sleep and exercise to reduce cancer risks.
Okay. Are they the number?
That could be said about any disease.
Yeah,
that would say that's my top two. But those are, again, that's going to help reduce your risks for literally all cause diseases. Yeah.
And it's free, and Mother Nature gave this to us.
Yeah, you're a bipedal walking human being, and you have the ability to walk. Go do it. Go exercise. But it's also interesting because our lymphatic system is tightly linked to our skeletal muscle.
Okay.
The lymphatic system being the fluid that moves our immune cells throughout our body. So skeletal contractions helps those immune cells move throughout the body to be able to not only combat infection, but also combat tissue damage. Because our immune systems have like a two-pronged approach to dealing with our humanity, basically fighting pathogens and dealing with damage. But again, going back to your question, exercise is very strongly linked to reducing risks. And there's some really cool studies out now that show that even just minimal exercise can help not only increase the myokines that are associated with muscle health, but also increase lymphatic fluid movement and immune cell involvement within promoting anti-tumor immunity.
So you've just brought up a point that I was actually going to ask you at the start, and it was T-cell and immunity. So let's first focus on the fact that if you have a great immune system, does that help?
Define great immune system.
Okay, let's just say that you have a strong ability to fight off infections because you have a high, a strong immune system.
Yeah.
Is that going to be better? Because I think actually Peter says something like this. Like he says, if you've got a strong immune system, it's able to fight the cancer cells. Is that correct? Maybe he didn't say that, but
Okay, so that's complicated because oftentimes, assuming you're a I'll start here. Assuming you're a healthy human being, you're not obese, you have a relatively healthy amount of visceral adiposity, you frequently exercise, and your immune system is quote unquote healthy, capable of fighting off infection and dealing with, standard damages that come with just walking around being a human being. But cancer cells will often deregulate the immune system where they can to kind of like hide from it. So again, that's going to vary between people, no matter how healthy you are. That's why I say like it's important to exercise. It's important to get appropriate sleep, but the things that cancer cells will employ, independent of your state of health, are sometimes without your ability to control them.
Mm.
So again, I really don't mean that to scare people. You control the controllables in life. But when you have a cancer cell that's doing something that's evading the immune cell recognition, independent of how capable your immune system is, there are specific therapies, conventional medicine approaches that need to be administered to help to prompt the immune system to recognize the cancer again. And we not only utilize these in cancers, these are called immunotherapies. And sometimes cancer cells will upregulate specific proteins on their surface to suppress the immune cell from recognizing them. So one common therapy that we utilize now in the clinic is anti-PD-L1 therapy or immune checkpoint blockade. So basically when cancer cells make this molecule, it will bind to something like a T cell and prevent the T cell from activating against the cancer. So if we make an antibody that blocks that interaction, the T cell will do its thing against the tumor. So then you're promoting a situation where the immune cell can do its supposed thing against the cancer, independent of how good your immune system may be.
That's really interesting.
Yeah.
But then, okay, knowing what you know,
which is very little.
well, and that's scary, right?
Which is still more than
why
most,
have we
but very
not
little.
found a cure?
Every disease is extremely complicated. I think we've kind of nailed the head on that, but cancer is just so, I think a lot of people have this misconception that cancer is just like one thing. But it's a multitude of diseases that utilize a variety of different ways to continue to grow. And all of those mechanisms that kind of support tumor cell growth not only vary between tumors, but they also vary over time, even within one patient. There's evolution that occurs on a cellular level as cancers develop. And so the mechanistic implications with cancer and any disease limit our ability to cure cancer. And I will say this, we have cured cancer with conventional medicine strategies. Cure meaning that...
Like radiation.
Yeah, radiation or even chemotherapeutics. Chemotherapeutics are very targeted molecules, but they do have this negative connotation associated with them that because they, normal cells, they also utilize the same things often as cancer cells to support their own cell survival. So the mechanisms that govern these things, they often have overlap. So they're very complicated, but you can deal with the normal cells getting killed off and the cancer cells getting killed off. Over time, you can restore human health, but the idea is to target the cancer cells.
Yeah.
But again, like I said, we've cured cancer in many cases, but I think people need to understand that it's just not simple. Yeah, it's just not simple. And as somebody that witnessed firsthand what cancer can do to the human body in many different perspectives, not only personal, like I lost my mom to esophageal cancer, which is why I do what I do. Yeah. The only reason I started this was because I was confused, why we've been unable to cure cancer. And as I've continued along my studies, I realized it's not because we haven't tried. It's just because it's an incredibly complicated disease.
Yeah. And
we do everything we can.
And with esophageal cancer, was that due to smoking, or is that
a lot of factors?
Okay.
Yeah. So my mom was a chronic smoker, so I won't act like that wasn't a contributing factor. She also liked her alcohol. I grew up in an Italian American family.
Okay.
Or Italian Jewish family, my father's side. My mom loved her alcohol. She loved cooking for us. She loved eating. But we were always really healthy growing up. There are contributions between smoking and alcohol consumption, but at the end of the day, like my grandmother, her mother, smoked a pack a day since she was like 19, 20.
Did she live in Italy?
She lived here in the USA. Maybe in sometime in her life she lived in Italy, but she died when she was 93.
Oh, wow.
And my mom passed when she was basically 50. So even genetically similar people who had somewhat similar behaviors in terms of smoking cigarettes, it's much more than just smoking cigarettes or drinking alcohol. There's a lot of factors that go into play in developing cancer, just as any disease.
So to make this a really happy episode, how can we? I just got you to smile. What can we be doing every day to help in this endeavor for the people out there who are? I know that there is a lot of people who are just chronically scared.
Yeah. So what I'll say is educate yourselves.
Well, we'll start with screening first.
Yeah,
screening when you can.
Of course, yeah. But we all need to understand that being a human being, human health in general, as a part of our environment, is very, very complicated. So trying to educate ourselves to the best of our ability can understand why we should get screening, right? So if somebody just gets screened without understanding why they're doing it, they'll just suggest screening. But if we know why we're going to get the colonoscopy, why we're going to get mammograms, we can make better associations in our life and make better suggestions to other people about why they should be doing those things too, and educate them about how and why they should be doing them to reduce disease risks.
Okay, so we've got sleep,
exercise,
and just nutritious diet, education. What are you currently studying specifically?
So I currently work in a biotech company, and I'm working on an antibody pharmacology team. So we study immunotherapies.
Okay.
So basically, there's a way that you can synthetically produce antibodies. Antibodies are made by some specific immune cells in your body called B cells. But we can basically make our own outside of B cells synthetically.
And they're a good thing. We want
Yes.
these. Okay.
Yes, but we can make them in such a way where they can recognize two targets at once. An antibody is a Y-shaped molecule.
Yeah.
Typically, they only recognize, both ends of the Y. Basically, they recognize one molecule. We can engineer them to recognize two. So one will recognize one thing, the other will recognize another. Typically, we engineer one to recognize something that's on the cancer cell and something that's on the immune cell. So that way they'll link the two. So if we know a particular tumor antigen or tumor-specific molecule, we can make an antibody to target that and bring an immune cell into proximity with it to enable it to detect it despite the cancer cell trying to evade it.
So when the cancer cell meets with the antibody, what happens then?
It essentially cross-links the cancer cell with the immune cell. It's just a linker to basically bring the two together like partners.
And then, so then do a lot of us have less B cell activity, less antibodies than other people?
Yes.
Okay.
Yeah. So everyone's ability, not even just B cells, everyone's immune systems are just wildly complicated. And honestly, like I'm not an immunologist, but the immunology that I've taken in terms of coursework, advanced immunology, it's just wildly complicated. There are amazing differences even between, like if I had a genetically identical twin, even our immune systems would be wildly different depending on the antigens we were exposed to, the pathogens in the environment, our skin makeup, not makeup, but like the pathogens on our skin, fungi, bacteria, even within our own intestines. Those things govern how diverse our immune system will be, even outside of genetic things.
So you could say even, improving gut health would probably be.
And a lot of that is dietary as well.
Yeah.
Yeah.
And you mentioned Metamucil.
Yeah.
Okay.
So I also suffer from like IBS as an example.
Okay.
So one of the things that I've recently been trying to do, and this isn't, something that I've always done, which shamefully I've not always eaten enough fiber. But one thing I've recently done is trying to eat more fiber to help, reduce the amount of inflammation that I experience after, consuming pretty much any food. I'm also controlling the fermentable foods that I'm eating.
Mm-hmm.
Certain foods have different ability to be basically consumed by the bacteria within your large intestine and produce gas.
Mm-hmm.
So I've been trying to reduce the intake of those foods as much as I can.
Yeah.
But that comes with knowledge of what fermentable foods are and things like that.
I hate fermentable foods. I just can't.
Can you give me an example?
I can't have sauerkraut, for example. Okay. I just don't like the taste.
Okay. Well, I mean fermentable. So like fermentable by they're taken up by the bacteria and fermented.
I thought you
to
meant
produce
fermented.
Gas.
Okay. So.
Yeah.
Okay.
No, I don't know sauerkraut may have specific sugars that are readily taken up by the bacteria in your gut and produce gas. Okay. So sauerkraut might be one of those things you might want to avoid if it causes gas. I'm not sure of the fermentability of that though.
I read a book on Otto Warburg, and I want to know if you've done any research in the Warburg effect and if you could break it down for us and basically take us through what that actually is.
Yeah, so Otto Warburg was a phenomenal scientist. He's a Nobel laureate as well.
Yeah.
Back in the 1920s. And essentially his early discoveries revolutionized cancer research in that basically he found that cancer cells that he was taking from specific organs at the time and just like putting them in culture and petri dishes, they had this ability to take in glucose very, very quickly and metabolize it in such a way that was different from normal metabolism. So in normal metabolism, glucose enters the cell, it's rerouted into the citric acid cycle and utilized downstream for a variety of different energy purposes. But cancer cells were taking it in at such a great rate that they were essentially not going through a conventional glucose breakdown, basically. And one of the readouts of this was they were producing lactic acid. And so he found that they were taking in glucose and they were changing the pH of the culture media or the acidity. They were making it more acidic of the culture media that he was culturing cells in. So this was coined essentially as the Warburg effect. And so it's also been deemed as like a hallmark of cancer. So I started a series on Instagram where I've called it Cancer Biobasics, and I've tried to break down these hallmarks of cancers, one of them being the Warburg effect as an association to dysregulated metabolism that's frequently seen across all cancers.
Yeah.
So all cancers will utilize this Warburg effect to some degree to increase their uptake of glucose, and one of the metabolic outputs of that is increased production of lactic acid.
Yeah. And this is why I think zone 2 training is effectively great, because you're training within that. Or have you got something to say regarding zone 2 training, like the relationship? Because when I was reading about the Warburg effect and then I listened to Inigo Samalon, he speaks a lot about lactate and training in zone 2.
Okay, so in zone 2 training, I don't know what zone 2 training is, but contextually is zone 2 training basically when you train to such a degree that the endurance of your muscle tissue produces excess lactic acid?
You're basically training within the mitochondria to not go over 2 millimole.
Okay, yeah. And this is related to the Cori cycle, I presume?
Yeah.
Okay, so the Cories were also in the same time as Otto Warburg. Cories both, I can't remember their names, but Gertie Cori and her husband, I think they were both Nobel laureates, but they worked in the same research basically. But regarding training regimen and lactic acid production, I don't think that it necessarily matters so long as someone's actively and consistently exercising regarding cancer risks. But again, I also don't know about the specific links that lactic acid production can have in what I think maybe you're alluding to is worsening cancer. Mm-hmm. Am I assuming correctly?
I'm not sure.
Okay.
Yeah. So we've got good gut health, exercise, sleep well, prevention via getting good screening, definitely limit alcohol, which we know, and limit sugars.
Yeah. And educating yourselves about all these things.
Amazing.
Yeah. And how do you do that? By listening to this podcast.
Listening to this podcast, doing as much as you can. It's the exact same with Alzheimer's disease. Getting amongst people who can help you break things down, and you just got to do your own research. Obviously not be your own doctor, but it's also finding a good doctor that can help educate you as well along the way.
Yeah. And that's it too, is like, it's easy to do your own research, but it's hard to do your own research the right way. And a lot of times that takes good mentorship. So as I said, everyone can do their own research, but oftentimes we need good teachers as well.
Yeah.
And so anybody listening, if you need somebody to help you learn how to interpret research, I know Louisa will also help too. But again, it requires good mentorship to be able to interpret, analyze, and be able to apply the things that we read to our lives to make healthy, impactful choices.
So you're doing a lot of education on social media. So where can people find out more about you?
I am only on Instagram. I've tried doing TikTok, but with little success because my stuff is typically a little bit more complicated and longer form content. Basically just Instagram and I guess LinkedIn.
Yep. Okay. Yeah. We'll point people towards there.
Yeah, sure.
Joe, thank you so much for being part of the Neuro Experience podcast.
Yeah, thanks for having me. I really appreciate it.